Understanding Python variables, your data containers. Variables in Python are like labeled containers in your computer's memory, used to store data. What makes Python unique is its dynamic typing. Unlike some other programming languages, you don't need to explicitly declare what type of data a variable will hold. Python automatically figures it out based on the value you assign to it. For example, if you write age equals 25, Python knows that age is an integer, or a whole number. Similarly, name equals Alice tells Python that name is a string, which is text data. And isStudent equals true creates a boolean variable, which can only be true or false. In Python, variables don't actually store the data itself. Instead, they store references to data objects in memory. When naming variables in Python, there are some important rules to follow. Remember, variable names must start with a letter or underscore, cannot start with a number, and can only contain alphanumeric characters and underscores. Also, variable names are case-sensitive, so age, and ag are treated as different variables. When you create or reassign variables in Python, memory is allocated to store the data objects. Let's see how this works. When we reassign x from 10 to 20, it now points to a new location in memory. When you reassign a variable, Python creates a new object in memory and makes the variable reference that new location. The old data may still exist in memory until Python's garbage collector removes it. Let's look at an example of Python variables in action. Here we can see variables being created, used in calculations, and even see what happens when errors occur. When working with variables, it's important to use descriptive names and be consistent with naming conventions. Also, be mindful of the data types you're working with to avoid unexpected behavior in your code. To summarize what we've learned about Python variables, they are containers for storing data values. Python uses dynamic typing, so you don't need to declare variable types. Variable names must follow specific naming rules. Variables store references to objects in memory, and using descriptive names makes your code more readable and maintainable. Python data types classify what kind of values variables can hold and determine what operations can be performed on them. Python offers several built-in data types organized into categories. These include numeric types, text type, Boolean, sequences, mappings, and sets. Let's start with numeric types. Python has three: integers, floating point numbers, and complex numbers. Integers, or int, represent whole numbers like 10 or -5. Floating point numbers, or float, represent numbers with decimal points like 3.14159. Complex numbers have both real and imaginary parts like 3 plus 4j. Next, let's look at text and Boolean types. Strings, or star, represent sequences of characters enclosed in quotes. You can use single or double quotes to create strings. Booleans, or bool, represent logical values, true or false. They're essential for conditional statements and logical operations. Strings support various operations. For example, you can find the length of a string, access individual characters by index, convert to uppercase, and concatenate strings together. Python has several sequence types. Let's examine lists, tuples, and ranges. Lists are ordered, mutable collections that can store items of different types. You can modify lists by adding, removing, or changing elements. Tuples are similar to lists, but they're immutable, meaning once created, you can't change their content. Ranges represent immutable sequences of numbers, commonly used in loops. Now let's explore Python's mapping type, the dictionary. Dictionaries store data as key-value pairs, allowing fast lookups based on keys. Keys must be immutable types like strings, numbers, or tuples. As shown in this code example, dictionaries support various operations including creating, accessing, modifying, and iterating through key-value pairs. Python also has set types for working with collections of unique elements. A set is an unordered collection of unique items. Sets are mutable, so you can add or remove elements after creation. A frozen set is an immutable version of a set, which means once created, you cannot modify its contents. Sets support mathematical operations like union, intersection, and difference. These operations make sets particularly useful for eliminating duplicates and comparing collections of items. Python also has a special type called none type, represented by the none keyword. None represents the absence of a value or a null value. Understanding mutability is crucial in Python. Data types are either mutable or immutable. Mutable types like lists, dictionaries, and sets can be modified after creation. For example, you can add elements to a list without creating a new list. Immutable types like integers, floats, strings, and tuples cannot be changed after creation. Any operation that appears to modify an immutable object actually creates a new object. By choosing the right data type for your variables, you can optimize memory usage, improve code clarity, and ensure that your program behaves as expected. Understanding Python's data types is fundamental to effective programming.